Ever wondered if there's a mysterious planet lurking at the edge of our solar system? That's right, today we're diving into the enigma of Planet 9. First off, Planet 9 isn't just a figment of science fiction. Scientists believe it might actually exist, hiding far beyond Neptune. But why haven't we seen it? Well, this elusive planet is thought to be about 10 times the mass of Earth and orbits the Sun at a staggering distance. Imagine taking a trip that would last between 10,000 to 20,000 years just to make one full orbit. Astronomers have spotted strange gravitational effects on objects in the Kuiper Belt, a region of icy bodies beyond Neptune. These anomalies suggest something big is out there, tugging on these distant objects. Could it be Planet 9? Now, you might be thinking, if it's so big, why can't we see it? The sheer distance makes it extremely faint and hard to detect with our current telescopes. Plus, its orbit might be tilted, making it even trickier to spot. But wait! We can detect exoplanets, galaxies light years apart, but not then Planet 9? So, is Planet 9 fact or fiction? Or all the science in astronomy is just a fiction? It's time to ask the big question. Where could this elusive planet be? Due to its extreme distance from the Sun, Planet 9 would reflect very little sunlight, making it difficult to spot with telescopes. If Planet 9 exists and is close to its perihelion, astronomers could potentially identify it based on existing images. However, if it's near its aphelion, the largest telescopes in the world would be required to catch a glimpse of it. And if the planet is currently somewhere in between, many observatories could have a chance to spot Planet 9. In fact, a 2019 study estimated that Planet 9, if it exists, may be smaller and closer than originally thought. Will our telescopes finally catch a glimpse of this hidden world, or will Planet 9 remain a tantalizing mystery? Because the planet is predicted to be visible in the northern hemisphere, the primary search is expected to be carried out using the Subaru Telescope. This telescope is equipped with both an aperture large enough to see faint objects and a wide field of view to shorten the search. Two teams of astronomers, Batygin and Brown, as well as Trujillo and Shepard, are spearheading this monumental effort. Both teams anticipate that the search could take up to 5 years. Initially, Brown and Batygin narrowed the search area for Planet 9 to roughly 2,000 square degrees of sky near the constellation Orion. Batygin estimates that this swath of space could be covered in about 20 nights of observation using the Subaru Telescope. Thanks to subsequent refinements, the search space has been reduced to between 600 and 800 square degrees of sky. In December 2018, they dedicated 4 half-nights and 3 full nights observing with the Subaru Telescope. To increase the chances of detection, it has been proposed to use a variety of methods and tools, ranging from different telescopes to multiple spacecraft. In late April and early May 2020, Scott Lawrence and Zeev Rogozinski suggested using multiple spacecraft, as this approach offers advantages that land-based telescopes do not have. The search of databases of stellar objects by Batygin and Brown has already excluded much of the sky along Planet 9's predicted orbit. The remaining regions include the direction of its aphelion, where it would be too faint to be spotted by these surveys, and near the plane of the Milky Way, where it would be difficult to distinguish from the numerous stars. This search included the archival data from the Catalina Sky Survey to magnitude 2122, Pan stars to magnitude 21.5, and infrared data from the Wide Field Infrared Survey Explorer satellite. In 2021, they also searched the first 3 years of data from the Zwicky Transient Facility without identifying Planet 9. The search of the ZTF data alone has ruled out 56% of the parameter space for possible Planet 9 positions. As a result of ruling out mostly objects with small semi-major axes, the expected orbit of Planet 9 was pushed slightly further away. Other researchers have been conducting searches of existing data. David Gerdes, who helped develop the camera used in the Dark Energy Survey, claims that software designed to identify distant solar system objects, such as 2014 UZ224, could find Planet 9 if it was imaged as part of that survey, which covered a quarter of the southern sky. Michael Medford and Danny Goldstein, graduate students at the University of California, Berkeley, are also examining archived data using a technique that combines images taken at different times. Using a supercomputer, they will offset the images to account for the calculated motion of Planet 9, allowing many faint images of a faint moving object to be combined to produce a brighter image. A search combining multiple images collected by WISE and NEOWISE data has also been conducted without detecting Planet 9. This search covered regions of the sky away from the galactic plane at the W1 wavelength and is estimated to be able to detect a 10 Earth mass object out to 800–900 AU. Milena Rice and Gregory Laughlin applied a targeted shift-stacking search algorithm to analyze data from TESS sectors 18 and 19, looking for Planet 9 and candidate outer solar system objects. Their search generated no serious evidence for the presence of a distant planet, but it produced 17 new outer solar system body candidates located at geocentric distances in the range 80 to 200 AU that need follow-up observations with ground-based telescope resources for confirmation. Following the discovery of Neptune in 1846, there was considerable speculation that another planet might exist beyond its orbit. One of the best-known theories predicted the existence of a distant planet influencing the orbits of Uranus and Neptune. Percival Lowell, after extensive calculations, predicted the possible orbit and location of this hypothetical trans-Neptunian planet and began an exhaustive search for it in 1906. He referred to this mysterious object as Planet X, a name previously used by Gabriel Dalit. Clyde Tombaugh continued Lowell's quest and in 1930 discovered Pluto. However, Pluto was soon determined to be too small to account for Lowell's Planet X. The search continued, and after Voyager 2's flyby of Neptune in 1989, it was revealed that the differences between Uranus's predicted and observed orbits were due to previously inaccurate measurements of Neptune's mass. Attempts to detect planets beyond Neptune by indirect means, such as observing orbital perturbations, date back even before the discovery of Pluto. In 1880, George Forbes postulated the existence of two trans-Neptunian planets. One would have an average distance from the Sun of 100 astronomical units. Forbes' work bears a striking resemblance to more recent Planet 9 theories, proposing that these planets could explain the clustering of aphelion distances of periodic comets near these vast distances. Fast forward to 2004, the discovery of Sedna, a dwarf planet with an exceptionally peculiar orbit, reignited speculation. Sedna's orbit is detached, with a perihelion distance of 76 AU, too large to be influenced by Neptune. Several researchers propose that Sedna's unusual orbit might be the result of an encounter with a massive, yet unknown, planetary body. In March 2014, the discovery of a second sednoid, 2012 VP113, with a perihelion distance of 80 AU, led to renewed speculation. Could there be an unknown super-Earth lurking in the distant reaches of our solar system? At a 2012 conference, Rodney Gomes proposed that an undetected planet could be responsible for the orbits of some extreme trans-Neptunian objects, ETNOs, with detached orbits and the large semi-major axis centaurs, small solar system bodies that cross the orbits of the giant planets. Gomes suggested a Neptune-massed planet in a distant, eccentric, and inclined orbit might be the culprit. In 2014, astronomers Chad Trujillo and Scott S. Shepard noted the similarities in the orbits of Sedna, 2012 VP113, and several other ETNOs. They proposed that an unknown planet in a circular orbit between 200 and 300 AU was perturbing their orbits. Later that year, Raúl and Carlos de la Fuente Marcos argued that two massive planets in orbital resonance could explain the similarities of so many orbits. Whether it's Planet X, Planet 9, or another celestial body entirely, the quest continues.